everyone. Welcome to Code Camp. Thanks for those who stopped by this early in the morning and for those tuning in online. Today we're going to talk about the future of C#. I'm Scott, and for the last month or so I've been working at Grubhub, so I'm still relatively new there. I also put my slides online. They're not up there yet, but they will be on a little later today. So if you want, the URL's up there with the QR code to check out for all the slides and all the demos that we'll go through today. If you want to email me, want to talk anything personal, use my personal email address. If you're interested in a job, send your resume to. Now, come talk to me if you want to. Grubhub is hiring. It's a really cool company. And I've been able to work remotely, so it's a lot of cool opportunities, and I love to work with other awesome people. So that's my only spiel for that. Let's get going. So before we start going into what's up with C# and where it's headed into the future, I just want to take a look at what the community thinks of it. And this is something that the Microsoft guys do every time they give a speech. And the 2018 developer survey from Stack Overflow was just released last week. So fresh statistics. And let's just look at 3 language survey questions. One is, what language do you love the most, or most loved? And I just have the top 10 up here. There's some, not too surprising by the ones at the top, but luckily C# is in that list. It's about the same position as last year's survey, so that's consistent, that's good. Most dreaded. All right, VB6 is up there, so that looks legit. And COBOL, although I'm surprised, not really. Luckily, C# did not make this list, so we're good. If you go online to the survey results, they do list about the top 20 or 15. Java does make the list, which I just started working in, which is interesting. But C# is not on there at all, and it wasn't on there last year, so no one hates working in C#, at least not the majority, so we're good. And then they also ask, what language are you most interested in? What would you like to work in for your next project? And although C# slipped a few spots in this last year, it's still in the top 10. Don't worry about the percentage numbers, they're all relative. So there's more than 8% of people want to use C#, I'm sure. So that tells us that C# is still relevant, it's still out there. There's still enough people using it that want to use it, and no one yet hates it. Hopefully that doesn't turn into it eventually. So that's still very encouraging to work on the language, to be involved in it, to see it grow, and where it's going to take us all in the future. So before we talk about the future of C#, we'll just talk about where it was and where it is. So of course we started with a 1.0 release back in almost the turn of the century. There was actually a version 1.2, so I didn't realize this, and I've been giving similar talks for the last couple years, and I've always skipped over 1.2. But I was trying to see last year, C# 7.1 was released, and there were some people calling it the first point release of C#, and the internet was readily available to tell them no. So there actually was a very small release back in 2003, I think, of C# 1.2. It was just a bunch of compiler tweaks. Some of them were breaking changes, so hopefully no one got bit by that. Version 2.0 had a lot of major changes. This came out with .NET Framework 2.0 and introduced generics, amongst other things. This was a really huge game changer for the language. With version 3, we got LINQ and all the wonderfulness that came with that, expression trees, lambda expressions, anonymous types, and then we also got auto properties for making the backing feel just a little less painful. C# 4 came dynamic. And also notice a trend here. There's less and less features, relatively, in each language version. And 5, async was a huge deal. It took a lot of engineering effort to get that out there. But what was happening at this point was the compiler was aging. At this point, the compiler was probably close to 15 years old, maybe a little bit older from the early alphas of the code base. And it was written in C++. It was written using older practices, and it was hard to maintain. But not only that, because it wasn't just the compiler, it was Visual Studio's tools. Everything that Visual Studio was using to give you the squigglies and to guide you on your development journey, all of that was completely separate from the compiler. And it took a lot of effort to get new features into both those code bases, especially since they were aging and not terribly well at that point. So they worked on a new compiler from scratch, written in C# for C#. And that was one of the very first projects released with the open source .NET Foundation. And ever since that, I think about 4 years ago at this point, .NET's really had a resurgence. The online community, the open source community around the development has just been amazing. You saw all these great new features coming out, all this great community development. And it really is an exciting time to be a C# developer. So with version 6, we got a lot of stuff. And every version prior to this had kind of a theme to it, and that's what all the features were supporting. But in 6.0, really they just went for like the last couple things, the top 10 or top 20 things that all the developers were asking for from the language for a very long time, but they weren't able to deliver. So there's some small things like null propagate, well, maybe that's not small, the name of operator. You know, some of the things that help us in the day-to-day, but because it was such a hassle to get these features in the language, it just wasn't on the top of the list. So the new compiler is called Roslyn, and it makes it a lot easier now to expand the language. And with it being completely open source, we got more eyes on it than ever before, and a lot more people are contributing towards that code base. And it's just taken off from there. So about a year ago at last year's Code Camp, it was right before C# 7.0 was released. So we went through all the great awesome stuff there, lots of awesome stuff, and lots of stuff too, just like with 6.0. There's a lot of new things that came out, tuples, deconstruction, and throw exception. Just some of them are little features that make your day-to-day programming a little bit easier, and some of them, like tuples deconstruction, right, really give you a new way to use the language. And then since then, they started with point releases, and we've really been on a good roll with that, with a very good cadence. So 7.1 came soon after. This was pretty much the backlog for what didn't make it into 7.0, and that's fine, that's perfect. They didn't want to rush those features. They were able to do a smaller release later on and get them in there and make sure that they were at a good level of quality. And this, so in 7.1 you got async main, so if you're using async and you're creating a console application, you would always have to terminate the task at that point. But now the compiler supports allowing you to make it an async main, so you can just follow it all the way through. A little bit nicer. Default expression, the default keyword now can be used with tuples. We'll try to show you that a little later. It's a little hard to explain, but just a nice little feature. Pattern matching was first introduced, didn't have great support for generics, and they fixed that in 7.1. And then there's a small tuple feature, I'll show you that a little later in a code sample, called main projection, just a little nicer way of working with and declaring tuples. 7.2, that was the most recent release and the current version of C#. We got, it kind of was a theme here, and it was kind of focused around more low-level, more memory management, memory-sensitive tasks. So we do have private protected, which is a new access modifier. .NET, the actual CLR, has supported that for a very long time. C# never had that exposed, so now that is available, along with a whole bunch of ref stuff. We're not really going to go through that a lot today. There's a lot of stuff online if you want to look into that more. But if you are doing a lot of low-level memory management manipulation, you might want to take a very good look at 7.2. And that's where we stand today. So now we'll just look at the future, and we'll go from there. So the next version of C# that's on the deck is 7.3. It'll be released with Visual Studio 15.7, which just got into preview, I think it was 2 weeks ago? Preview 1 was either a week or 2 weeks ago, and preview 2 was Thursday. Now, there's not a lot of stuff in there for 7.3 yet, but I have a local build, so we can go through all that. Hopefully soon, maybe preview 3 or hopefully preview 3, a lot of those features from C# 7.3 will turn on. You can start playing with them without having to build everything locally. So that should be coming out imminently. Everyone knows familiar now with, they usually, I think, like 5 previews typically. So that'll have its way through. All those features, I've been playing with it for a while. They do feel really complete. I haven't had any major issues, knock on wood, with running these alpha bits in Visual Studio. So hopefully we'll have good luck today, and that means they're likely closer to a release than not. And then we'll look at the far future. So everything we're doing in 7.3 I can show you in real actual code demos. When we move to 8.0, I'm going to have to move to slides and code on slides, because most of this stuff is just conceptual. There's very little runnable code I can show you from 8.0. But combined with 7.3, that should come out relatively soon, and 8.0, which is probably still a little ways out, there are over 35 new features coming to C#. Some of them small, some of them really big. There's a lot of big stuff they've been working on for the last 5 years, I would say, that's going to finally make headway in C#8.0. So that's going to be really, really exciting. And then beyond that, there's also a whole bunch of other stuff they have in the works. So I don't work for Microsoft. I don't have any special insider information. And you don't need to, because it's all open source. It's all out there for everyone. So on GitHub.net, Roslyn is the source of truth for the C# and the VB, but it's C# language. It's the compiler for both those languages. And that's where, right, so if you want to see what's going on with the language, check out there. In GitHub, there is an issues tab. It's really used a bit more like a forum, if you will, in this code base. And it's really great to hop on there and see what all the lively discussions are. That's where people, anyone, can put in their new suggestions for the language and have serious discussions on it. Or there's threads that are almost like 2 years long about some of the 8.0 features that they're looking to add in. So everything is out there to see about how the language is progressing, and it's interactive. So log into GitHub. Feel free to comment away. I've done that a few times, and no one's yelled at me yet. So it really is more of a welcoming community. So I wouldn't really be too afraid of necessarily posting your ideas there. And I would encourage you to check it out. But then there's also another GitHub page. This one's called C# Lang, although it is both for C# and VB. And it's just a document repository. So it's where the spec of the language is supposed to live now. It's supposed to, because it's still being developed. It's a lot of stuff to write. The last spec for C# that was fully complete prior to this project was C#, I think it was 1.2 or something, or 1.1, 1.2. So it's still, it's not perfect. I would say it's eventually consistent. They post all the language design meeting notes there, so it's really interesting to see what's coming from there. All the proposals and all the milestones. So I want to show you that real briefly so you kind of know where you're going if you want to go to these sites. So first on the, we'll start here on the this is the C# Lang page. And there's a README and everything. What you really want to go for here is, there's a folder called meetings, which is quite interesting. So these are the raw notes from all of the language design meetings that they've been having at Microsoft or within the community involvement. They're not open for anyone to join, but they're open for anyone to see the notes for. And then so the issues here kind of acts like a forum. Well, definitely in this repo acts as a forum of discussing new features. Typically you see, like here's one permit stack allocated. So all these features are coming up here. But if you go to milestones, this I think is really interesting. This is where they try to give you the best idea of what's coming up in these future versions of the language. So these are somewhat accurate. Take them with a very large grain of salt. You're getting more of an idea than an exact promise of feature list. So 7.3, which is almost in beta, almost done with principal development, everything in there is quite accurate. In 8.0, you got 24 things in here. I highly doubt all of these will make it into C# 8. But they're all things that they're exploring, and we'll have to see how they develop. Where's my favorite one in here? My favorite one, I think it was this one. It was, or maybe it was C# 7.3. It was bestest betterness. So they're constantly working on improving the method of overloading logic to try to make it a little, every iteration tries to make it a little bit better. And they've been calling it better, best businesses, better businesses. So they keep on adding the adjectives on that. That's kind of fun. So if you want, even if you just come here, check out the milestones every once in a while to see what's coming up. That'll give you a good idea of where the language is going. On the other side, on the Roslyn side, they also have kind of a status update. If you go under docs, and then at the root level, there's language feature status. This I really encourage you to check out. So this is the code, so I would trust, this is a lot more accurate than the updates you can get on the other GitHub page. So this is telling you, gives you links back to that GitHub page and gives you links back to any issues talking about it. But it gives you like the branch links. So if you want to actually go see the source code, you can do that right here, or get to it from here. So this is really the ongoing development of it. So C# 7.3, that's pretty much the feature list. And 8.0, there's a lot of stuff, but notice status is all prototype or in progress, a lot of TBDs. So you can kind of tell where that is going. It still has a lot of development left to go. But so I'm going to later show you C# 7.3, and we're going to go through some features. And what I did to get that working is I downloaded the latest version of the feature branch and got that running locally. And you can do this too. So the branch I've been playing around with, typically the ones you are interested in, are dev 15. These are named after the versions of Visual Studio. So dev 15.7.x is going to be the branch I'm going to show you later, and we're going to work with that. I just downloaded that and built that. It really is easy to build. So if you go to the wiki, there actually is a lot in this wiki, and it seems that they do keep it quite up to date. I scroll past. There is a link, an article for building, testing, and debugging. So if you download the source code, these are all basically the same. There's step-by-step instructions on how to compile it and test it locally, and maybe the version of Visual Studio that it requires is a little bit off, but I've followed these instructions. I've never had any issue in the last couple of years, so they've really made it very accessible. So don't be afraid if you've never built it before. Maybe try on a weekend. You can. The way it installs, it doesn't screw up your Visual Studio. So worst case, there's instructions on here on how to undo the installation that it does if something really does go wrong. But besides, Visual Studio now is really quick to install. So worst, if you had to just reinstall it, that's not so much of a burden as it used to be. So there's really a lot of fun stuff with the community. Has anyone been out there to look at these pages before? So I really encourage, if you're interested in C#, check it out every once in a while. Really cool. Even some of the things go really technical, and I'm not even going to pretend I know everything that they're talking about. But there's enough of a cursory glance that really is quite interesting. So today, for the demo in C# 7.3, we'll be using Visual Studio 2017 15.7 Preview 2, which was released last Thursday. If there are bugs or things crash, please be understanding, because on top of that, I've installed, like I said, a local build from also Thursday of the master branch for this, for 15.7.x branch. So I did test it out this morning. Everything seemed to work, so hopefully we'll have good luck. And then, without any further ado, let's take a look at some of the new features in C# 7.3. Code, yes. All right, so first we're going to look at our tuples. So in C# 7, we introduced tuples, which is actually a different type than what was in the language before. If you're using older versions of .NET Framework, version 4.6 or older, you're going to have to add a NuGet package for supporting this new type. If you're using 4.7 or newer, or I think it's 4.7.1 maybe, I don't know the exact version offhand, it comes now shipping with the tuple support, so you don't have to worry about it. But Visual Studio will guide you if you try using the feature without actually having the necessary NuGet package. It'll guide you to install it. So we have tuples. There's a lot more things you can do with tuples, but that's a lot to get into for right now. In 7.2, I do want to point out name projection. So prior in 7.0, if you wanted to have names associated with these tuple values, you have to use the syntax of name : and then give it the value. But a lot of times that turned out to look something like X, X or Y, Y, really, really repetitive. So in those situations, and the compiler's telling me or giving me a hint, you don't have to do that anymore. See if I can just fix it here. Yes, use inferred member names. All right, we'll have to do it individually for each one. But if you give it a variable name, it's going to pick up on that variable name and use that for the names. Now you can override that if you want. You can still do something else. You can still do foo, and then it'll be called foo. So if you do point B, you'll get your foo and Y. But if you don't do anything, if you just give it the variable name, it assumes those, it projects them onto the type, and that's a little bit easier now to work with, because typically those names match. It might, yeah. So that's a really cool feature. Just a small little nicety to have. And then in 7.3, they added tuple equality. So if you wanted to compare tuples before, you'd have to do, it's possible, but you'd have to do point A equals point B. There were no operator overloads for those equals or not equals. So in C# 7.3, they've added that. And you can see, so even though these are different names, different arguments, the values should match. So if we run this, you can see that hopefully they show up as equal. Yes, it compiled. Okay, great. So that works. Now, I just want to also remind you, if you want to play with this around yourself, you're going to have to, if you're creating a new project from scratch, you're going to have to go in and change something in the properties. So in the properties, if you go under Build, there's an Advanced. You can choose what language version you wish to support. And it has everything back to so ISO 1, ISO 2, where the C#1, C#2, those were, I think, ISO C#2, the international standards. The default here is to use the latest major version. So if you just bring up Visual Studio and start a new project, you're not going to get 7.1, 7.2, or definitely not 7.3. You're going to get 7.0. And that's because there's so many, the cadence is so high, there's so many releases. For people working on large teams, it might be difficult if you start using a brand new 7.2 feature and the rest of your team's on an older version. So it kind of defaults you to go in that path. So if you know what you're doing, if you can get everyone's support that you work with, you can get them to either follow the latest minor version, which is going to be always the latest, or just pick and pin to a specific version. So where I used to work, we always had pinned it to a specific version because the compiler support's needed on the build agents. Everyone's Visual Studio has to be to a minimum version. Just a bit of an effort to coordinate. So we always pinned it to a specific version and used it as a rally call to get updated. Now, if you don't have that set, if you have an older version of C# selected, it's just going to give you compiler, not really compiler warnings necessarily, but errors in the IDE saying, yeah, hey, this is for a feature of other version of C# that you didn't choose. All right, so then let's move on to refs. So I'm not going to go too far into this. This can get really confusing. So there's just two features that I want to go over, three really. Not two. So there's ref reassignment. So local refs were introduced a little bit earlier, and you can use them. So we have two integers, a and b. You can now have a ref var, which is just a pointer, to a ref of a. And then if you change your pointer, the original a is going to change. Let's put a breakpoint here and see that. So I just did pointer equals 4, and pointer was pointing to a. So if I hover over a now, I don't know if you can really see that, but it says 4. I can't make that text much bigger. And then if we continue on, now we can set that pointer now to a different reference. Now this was not possible in previous versions of the language. It was something they wanted to do. There was no reason to hold it back other than just time and quality efforts. So now pointer is happily pointing to B, which is set to 2. We can move this forward and set it to 108, and B should be 108 and A should be left at 4. So all those kind of work as you'd expect them to. So just a little nicety, if you're working with pointers now, you don't have to, you may be able to create a little bit less variable names. If you're working with unsafe code, now I haven't in a very long time, honestly, ever since my days of, ever since I stopped writing web forms applications, I haven't written any unsafe code, no bitmap manipulations. But if you are, there's a nicety added. The stack allocated arrays never used to have the same support for array initializers as the rest of the language did. In C# 7.3, that has been corrected. So you can use all the different forms. You can be explicit to the size. You can infer the size, and you can still infer the type. Of course, these are pointers now. So if I hover over them, you're not going to get the values. You're just going to get memory sizes. You get the first value. But if we go into the watch window, let's get like the second index or the third index, and then we get that last 15 value. So just a little nicety, maybe a little less boilerplate code if you're writing a lot of unmanaged. There are some other unmanaged features which I'll mention at the end of the code demos in C# 7.3. I didn't want to go through all of them. They're a little harder to explain if you're not familiar with unsafe code. And there's a lot to go through. So next thing I want to show you is type constraints. This is my favorite feature of C# 7.3. So when you have a method, you can add a generic method. You can constrain what types can be given to that generic and satisfy that generic constraint. And you can do things like integer, string, your own types, interfaces. One thing that really did annoy me, I found a lot of different situations where I wanted to restrict it to an enum, and you never could. You could try to fake it by, I've seen some people that try to look at everything an enum implements and try to implement that, but that's really hacky. It doesn't stay up, it doesn't stay maintained, and it really doesn't express that you want this restricted to enums. So in C# 7.3, you can just specify enum. This is system.enum. It's not a language keyword. It's just a regular enum, and then it works. So here I have handle state change. I'm just passing in 2 enums. If I change one of those to, they have to match. It's a generic. If I change them to just integers now instead of an enum, now I get this squiggly saying you can't do that because they're not enums. Pretty cool. So I think that was on the wish list of a lot of developers, and now we have that. Let's get this back to compiling. Alrighty. Now, I don't know exactly what use cases the next one will have, but delegates themselves can now be specified for generic constraints. I've never really encountered a need for that personally, so I don't know what benefit that'll give you, but for those that have been wanting that, you have it. So similarly, system.delegate's now accessible, and here in the demo, I'm just going to dynamically invoke. Here, it's just a function that returns 7, so this result here would be 7. So let's run this, and all right, I can't run it. Why? Oh, okay, so there's another constraint introduced. And this one is a keyword. This is called unmanaged. And this is also going to be helping. This is ref related and low-level memory related. So unmanaged now has a very special meaning. So it has to be a structure, and the structure has to be composed of types which can only live on the stack. So the problem here is that string is a reference type. So I can't have that. That's not allowed in an unmanaged struct. It doesn't meet the constraint. So to satisfy, I'll have to undo that. And then the constraint is satisfied, and I can compile. So the enum, yep, that works. Really want to show you here in delegates. We're going to run that delegate, and we're going to get the result. So some of the breakpoints aren't moving around. It's a alpha version, so that's what if you see those things dancing. And then the unmanaged gets hit. So if you are dealing with low-level memory and you had to always resort to complex reflection or other sorts of tricks to make sure that if someone's passing your library a data structure, that if you make sure that can be fully represented in native memory, that it can go back and forth without issue. Now that's supported by the language and the compiler. So that's really cool. I think that'll help a lot of people. And enum, I know, could benefit from that one. So that's pretty cool. Okay, another improvement is patterns. So it's not new patterns, but patterns that can be used in new places. So again, due to time constraints, there were some restrictions as to what you can do with pattern matching, the out var and the is checks in C# in previous versions. So now you are allowed to use these constructs in constructors, in fields, and in link query clauses. So I'll show you the query clause first because it's right up here. And this worked a little bit different than I would have expected it to. So in the query, you can select an item from the data. You can do where item is int, that's the pattern that we're checking for here, and capture that result of value. And then you can use value to do additional checks as part of your where clause. You don't have to do as much casting in there. What I really wanted to be able to do here was also return value, but I can't. It's not in scope. The scope is only for the rest of the where clause. Now that can still change, and these things have changed late in the game in previous versions, so we'll see. But for right now, it's still going to save you some time. You don't have to do the casting. It looks a lot nicer, a lot more expressive. For the constructor, let's say here's a base constructor that takes an int value. And then I'm going to inherit from it, but I need to take a string for some reason. So I need to parse this out and pass it in. So you can do it a lot nicer now. You can just call int.tryParse, capture the variable using the outvar pattern, and then you have access to that in the rest of the call. So you can parse it and then pass it in to the base constructor. But here, if you want to use it in the constructor body, it's also still in scope. So there's a lot of options you have available to you there. So I'll put a breakpoint at the end of this to show you that the scope works. And I'll put a breakpoint at the query list to show you that it should come out to familiar numbers. The ha-ha-ha and the date time now should be filtered out because they are not of the int. And then the for and the each should not show up because they're not greater than 10. So we'll run this. And here we do see I passed in the value of 108. I is now set to 108, and then I'm able to access that still within the body. And then with the query results, we do see that expanded to 15, 16, 23, 42. Everything that we specified was met perfectly fine. So the goal of this is to allow your code to be a lot more expressive, to read a lot more like English and what it's trying to do, and for you not have to repeat yourself. So if you weren't able to capture this before, you'd have to then cast it in another where clause or use a let statement, and it gets a lot more complicated. So that's a lot nicer of an option if you're doing a lot of that, if that applies to you. The last thing I want to demonstrate for you from C# 7.3 are backing field attributes. So with properties, there's a lot of different ways to automatically declare when you can make them read-only, you can make them read-writable, you can initially set a value. There's a lot of things you can do with properties now. But if you need to do something with serialization, if you need to, for some reason, decorate the backing field with an attribute, before you had no ability to do that. That backing field was generated by the compiler, and you as a developer had no access to that at all. And through reflection, you can see it, but you can't affect how that gets generated. And you still don't have control over the name, but you can now apply fields to it. So if I were to omit the field, this attribute would apply to the property itself. But with adding the word field : and I think we've had this in the language for a while for events, just not for properties. This will then apply to the backing field of the property. So to show you that this actually works here, we're going to reflect upon the foo. We're going to get all the instance non-public types to find that private integer created. There's only one of them, so single is pretty safe in this demo, and then we're going to get that list. So we should see in there. So you see the non-serialized attribute that I added on. And then we also see a few things that the compiler put in. One, that it's compiler generated. So that is, read that as compiler generated. You omit the attribute when you're reading these things aloud. So compiler generate, just letting, noting that this was not a written code. That affects when you're debugging. Also debugger browsable. So if you're stepping in code, it's not going to step in, unless you tell it to, into code that's compiler generated. So there's a whole bunch of things that all go on there automatically, and then you also see this. If I entirely run this attributes, compiler puts. Bugged you, had a situation that prevented you from properties. Those are all the live code demos for back to questions. Yes. Sure. Yeah, any object type or any interface. Yes. You can't use the regular constraints, so you can't do. I don't know if unmanaged will work. I don't expect it to. Maybe if I spell it right. Yeah, no. So yeah, it doesn't look like you can use that there. I don't. It's probably not the compiler. Yeah. So anything that's a type or a interface should be allowed. All right, cool. Let's move back to slides. And then, so that's everything that's coming out, but there are a few more features I just mentioned. I'll just walk through these really quick. If you're using unsaved code, Fixed has some new capabilities for you. It has some pattern matching support, and you can also index fixed fields without pinning them. So it keeps a relative offset to the start of the pointer, and then it resolves that at runtime. So it's a little bit easier in dealing with those. You don't have to pin as much memory, which is great. It lets the GC do more of what it needs to do. For improved, I told you a little bit earlier about bestest betterness. There's always the effort to make C#, make the overload selection mechanism a little more what you'd expect of it. So they're constantly improving that. So for situations where it's static method versus instance method, I don't really understand exactly what that's referring to, but that's okay. It's going to make a better choice. And then for situations involving generic constraints, it will now sometime the right conditions look at the generic constraint to make a choice, whereas before it would not really look at those at all. So now it's looking at more of the signature than it has before, and things should work a little bit nicer. Hopefully there's a slight chance that some of these things can introduce breaking changes to your code. I've never seen one myself. These things have been coming to C# for the last couple of versions. So best case, things that didn't work before magically do work, and you'll be a little bit surprised, and that's great. The other thing is, I didn't really want to show this, but it's really easy to talk about. If you want to declare a partial ref struct or a ref partial struct, the ordering of the ref and the partial was very important. It had to be ref partial struct, but sometimes partial ref struct makes a little more English, and it doesn't really matter. So they made the compiler a little bit more forgiving, and the order of those two no longer is important. So if that was bugging you, it's been addressed. It was bugging someone enough to get it changed. Now, some of these are also community contributions, so this is not necessarily what everyone at Microsoft needs to see in the language, but what everyone's using it is suggesting and sometimes implementing it themselves. There are a good number of contributors to the project that are not Microsoft employees or Microsoft related. So now let's look at C# 8.0. So now everything you saw is going to come out in the imminent future. It's probably going to look very close to what you saw today, and you can probably start playing with that maybe in Preview 3 and hopefully at least by Preview 4. So now for C# 8. These things are going to be a little more nebulous. Some things a little more baked than others. I'm starting with the most concrete, in my opinion, from what I've seen in the community, to least concrete, less likely to actually make it to C# 8.0. Nullable reference types will definitely make it in. I mean, pretty sure because they already have previews out there. So there is code you can download today, and it'll allow you to play with this in the compiler, in the browser, in Visual Studio. I couldn't show you that today because there are some restrictions. It has to be on 15.6. And you can only have one version of Visual Studio installed. So I wanted to show you the 7.3 features more, so I'm not going to be able to show you real code of this. But if you want to go home and try it out yourself, you're more than welcome to. You just have to have 15.6, some update, some version of that, I think 15.6.4 or greater, and then just be sure that's the only version of Visual Studio you have in your machine, so it knows which one to always pick. So if you just want to, if you're interested in that, just come. I'll show you later if you want to come up to me about where you can download that, or just search online for nullable reference types. It's in the wiki on this in the Roslyn code base somewhere. So the idea here is this is code I've written, or something very close to what I've written. And where I used to work, I got mixed reviews from code reviews. So a lot of times people would say, well, that null check at the beginning. So here I'm passing in a required attribute, a dependency, and like an optional one of some kind. So I'm checking to make sure in the constructor that the required attribute is actually specified. The benefits to throwing an exception here, then right upon creation, I know that there's an issue with this object rather than waiting until I invoke a method and then having to wonder what's null and what's not null. So it's very explicit here, and it's the reason I always include these checks. So because it's always easier for me as a developer to see it failed a constructor. It's very obvious what the problem is then. And then with the null argument exception, you specifically can add the name of the argument. So it's all very clear in the debugger where to go to solve your problem. But it is a lot of boilerplate, and a lot of other developers I used to work with don't agree that that's necessarily worth it. And nulls have kind of been a weird problem like that. It's always kind of awkward to figure out how to deal with them. And there's not a silver bullet solution, but there's new features coming to C#, which is going to make that a little bit easier. Now, this is actually kind of a breaking change. If by default now, any reference type cannot be null. And if you want a null reference type, you have to use the question operator to signify that. So in this example, I don't need my own null check anymore because the compiler is going to, in most cases, it's like 80% of the situations. I'll talk about that in a moment. In most cases, it's going to do the right thing and give me enough confidence that people are consuming the code correctly and that the code's written correctly. All right, so first, this is a huge change, and it would be breaking if it was introduced immediately. Everyone was forced to do it, and it started breaking your builds. So that is obviously not what they're doing. There's no intent to destroy the language. There's intent to grow it and give you new features. So this is going to be introduced very softly. The plan is to make it, first you have to opt in at your project or assembly level to, I don't know where this is going to be exactly, but to choose to enable this nullable reference types feature. And then at that point, it's going to generate warnings, not errors. So it's going to give you, and you're probably going to get a lot, because these things are cascading. So there's a caller to this method, right? Caller a foo. And let's say they get two arguments that could be null. So you're going to have to propagate these changes throughout your entire code base. But because we're going to be starting off as warnings, not errors, you can turn it on, do a little bit of that work, turn it back off. It should hopefully give you the tools to better track this stuff. And at some point, we'll see where this goes. If everyone loves it, I'm sure maybe it'll get a little stronger in its implementation, and it's opinionated in how you write code. If there's backlash against it for some reason, then it may not go anywhere. So we'll see. It's a nice experiment. I like the idea of where they're going to because it makes it very, very explicit as to what now should be null, what should not be null, kind of like what optionals do in some languages. So it's all enforced by the compiler. So down here now, the compiler is going to do, oh, you can't see my mouse, down here in caller foo. Now we're going to try calling foo. So I have a required dependency that's caller foo is not getting it required. It could be null. So the compiler is not going to allow me to write this code. It's going to give me that warning. Because there's no proof to the compiler that required is not null. So I could take off the question mark from the required dependency and force it to be null and push the problem elsewhere. That's valid. You want to push your nullables up to whoever generates the value originally. That's fine. You can do that. Or in here, you can do a null check to prove that it's not null. So we can wrap this around a null check, and the compiler is going to do flow analysis and see if that's the case. So it'll see that there's a null check protecting this method call and will now allow it. So this is where the 80% comes from. There's a lot of situations you can imagine where the compiler is going to have a difficult time analyzing the flow. In most cases, it'll probably do a great job, but it's not going to be perfect. So take that with a grain of salt. That's your warning. There might still be problems, situations you can get yourself into, and likely these, as they're discovered over time, they'll be addressed. But it's not a complete solution. There's still some ways to get nulls through, but it's good enough and it's a great starting point. Now, let's say another example. I have an announcer. It's just going to announce your name and how many characters your name has, how long your name is. Really silly, but that's what code demos do. So the caller is going to get your name from some kind of provider, has no idea about if it's null or not. And then it can check against null and call the announcer. But this is a string we're dealing with, right? So usually, a lot of times, you'd want to use string is null or empty. Now here you have a problem. It's the compiler making the flow analysis. So the compiler has access to all the code you write and has that all parsed and nicely sorted into a syntax tree in memory. It has really good flow analysis. The compiler is not a decompiler. It cannot go, it doesn't have the capability to go to this is null or empty as part of .NET Framework, the actual seal, the framework class libraries that ship. So it's not going to be able to go into that compiled code and do flow analysis because that's just not what it does. And they're not looking to add that capability to the compiler, maybe ever. So in this case, what they can do in the future is if it's compiled using this nullable feature, maybe put a marker in the assembly saying, hey, this is safe, I was compiled with this feature, it's okay. Or as a way to get around this, there is the, Mads called it the damn it operator. So when you know it can't be null, it's kind of forcing the compiler. It's saying you know more information than the compiler can deduce. So believe me, this is safe. Now, of course, this has it doesn't actually check whether at runtime. These are all compiled time checks. So at runtime, if it actually is null, things can happen. You broke your promise, whatever. So don't abuse those. Really only put them. They're really just intended for when you have another method that's doing a check that's not in your code base, so you can get its output and whether it's guaranteed to be not null or not. So this is really cool stuff. They're trying to address the feature. We'll see how this works. I'm really excited for it and see where it goes. I know you can be divided on this one. But that's in a pretty good shape. You can download the demo now and play around with it, and that's probably going to be in C#8. Some other things that are adding are, I call them concrete interfaces. It's not the real name. But in C, well, let's go through a demo first. We have a foo bag, and there's a method called add foo. And then we have a class. It may or may not be in my code base. Maybe it's someone, depending on my code base, that's implemented this. And they've implemented foo, everything's fine. And now I need to make a change. So I could do iFooBag2 and introduce a whole new one, and then foobag would implement iFooBag and iFooBag2, and it's really hard to maintain, kind of ridiculous. So in new versions of C#, hopefully 8.0, if you were to add this breaking change, obviously now foobag is in compliance, but you can provide a default implementation. Interfaces can now have implementation code. So they only have access to what the interface knows about. Because add foos can be composed of just add foo, right? The singular instance, this is pretty easy to write an implementation for. And then all the other classes don't have to worry about it. So if they're not under your control in different assembly and you want to add something, you can do it this way and you're fine. If you have a lot of implementations for some reason and don't want to go through updating them all or want to do it in a future story, you can do this temporary approach. Now, the implementer can still override this. Right now, it is the override operator here, which personally I think is a little confusing, because this looks like it's overriding from if there was a base class. It's not clear it's coming from the interface, so we'll see where that evolves, but right now that's what they're going with. And then you can override that. For example, instead of iterating through every single list item, there's an add range method I can call, which might be more efficient. So you have those options now. Now, a primary driver for this is Java has this feature, and Swift has this feature. And with Xamarin, there's a lot of cross-platform development. So C# needs to be able to represent the constructs and interfaces from other languages, from Java for Android and from Swift for, of course, iOS. So that's a large driver for this. I think this one is going to require, though, an actual CLR change. So this is going to be a lot harder to implement across the teams. I think so. Yes. Oh, sure. I'm sorry. Yes, yes, I might. You guys are not. So your question was, what's the difference between an abstract class and this? Let me go back the slide. Right. So there's some similarities. I don't yet fully internalized quite when you'll use one or the other. I do understand that now there's some overlap in functionality. For one thing, though, you can implement multiple interfaces on a class. You cannot inherit from multiple classes. So if there's multiple interfaces, that's okay. But for abstract classes, you're limited to just one parent. So it kind of introduces some kind. Yeah. Yep. Yeah, there is some overlap, and there might be some situations where you can choose between them. It's primarily added, though, for the compatibility with other languages, and you'll see that there's some other cool features we can build on top of that. So we'll get to that. Next thing I wanted to show you is extensions. So in C# current, every version for the modern era, you can add extension methods. So you can have a static class with a static method, and the first argument could be this of something. I'm going to say a reptile. And then when you go to do reptile or an instance of reptile will appear to have this extension method on it. It'll look like it's part of the object. And that's been in C# for a while. It's been enhanced in the past. So things like array initializers, things like deconstructors, those interfaces now look to extensions to look for missing gaps in implementation. But it's still pretty basic. You can only do this with methods, and there's the desire to do it with a lot more things. So, and I've just stolen Matt's slide here because he has a really good demo of all this stuff. So this is not my doing. But now there's a new extension type in C# 8.0. And you can then, within this body, declare anything. So it looks like you're declaring a class, but you're actually extending the class. So this is not inheriting from it. It's creating a similar structure that you had before, but there's now a way to express static fields, instance methods, instance properties, static properties, anything you want, because it's all valid code that you would write a class with. So it's really kind of intuitive if you're coming from that approach. So that's pretty interesting. And then with this, they're also looking to introduce a static method so that interfaces can actually define static requirements of the type they apply to. So this is another demo that's been going around that I've been seeing. So it's just going to be it's called some monoid or whatever. It's just a simple interface with an operator, a plus operator, and some kind of self-identity unit. So we can declare this theoretically in the future. And then it's pretty cool. You can combine these with extension methods. So for example, int has operator plus support, but it's missing unit support. Well, we can now write an extension method that adds a static unit support, and the identity number in addition is 0, so that's what it's looking for there. So you can say that this, you can kind of write the glue. So if you want to use an int, it can satisfy this interface with the addition of this extension. So that's pretty cool. So you can have a static, you can have this generic method sumAll, and it's going to take in a bunch of values, and it can actually now use the interface as a generic constraint, but the compiler is going to be smart. If you're passing in an int, it's going to see that it has extension methods, see that those extension methods are good enough to implement the interface, and then you're good. So it's not quite duck typing because you have to explicitly create that relationship with the extensions, but you now have the ability to allow implement interface implementations to classes that are sealed or classes after the fact. Pretty cool. There's a lot of fun things you can do with this. This is actually pretty much type classes, which is a feature that Haskell's had, which C# aficionados have been looking to take into the language for quite some time. So an earlier version of this was using the word concept. It then had the keyword instance to make the relationship, and then the calling code was kind of crazy. This looked nothing like C#. Like the implicits, all the stuff down here, I'm not gonna go through it all, but this does not look like C# code to me. This does not have the feeling of C#, and that's really important. As the language evolves, the designers want to make sure that everything still feels cohesive, and I don't think this does. So this was a previous version. Now they're trying to use extensions and interfaces, new features there to provide some kind of type class feature. Whether that'll be enough, we don't know yet. That they're still in experimental stage. We'll see where that leads, but it is very promising because the two can really match up quite nicely. There's an async improvement, so an enumerable improvement. So if you had an array or an enumerable coming back, and each call is an async call out to a service, let's say, you would have to write that code yourself. There's no way of actually having that automatic for you. So there's a new interface being added, async enumerator, and async enumerable, and async disposable. All these kind of work together. Very similar to enumerable, enumerator. I'm not going to go into too much detail about that because it's so similar. And you could write this code. So you could get the enumerator, iterate over it. You'll wait on each move next, because each move next is theoretically calling another service or talking even to the file system or something that's going to take a while. So you can await on those, and then when it comes back, continue on and do something. You can have awaits and finallys now, so now we can also do an await dispose when everything's done. So of course, that's incredibly ugly code. So we have syntactical sugar for these situations. And in C#8, it's the for each await. The syntax of this can still change slightly. Where the await word has the preference where people want that is kind of moved around, whether it's in the parentheses or outside. But this looks like it's the preference right now. So you'll have that capability if that's a feature you like to use. This feature is actually called async streams. I thought that was a little confusing because it's enumerables, not streams. It's like a stream of objects, I guess. But there is the concept of streams in C#, so I want to keep that separate. We're done. Then this is likely not going to make it in. They've been talking about records for the last 4 to 5 years. The idea is kind of like tuples that we have today, but immutable, and some language features to make dealing with immutable types a lot easier. And they felt this pain. Roslyn, the new C# compiler, is entirely written based off immutable objects. And it's kind of ugly to deal with immutable objects in C#. So this is an attempt to improve upon that a little bit. So this would be a full declaration for a type right here. This is completely valid. They're not missing a brace, maybe missing a semicolon, but that's it. And that breaks out to, you can do classes, seal classes, abstract, whatever. And this breaks out to this code, which you don't have to understand in detail, but it gives you properties. It makes them read-only. It accepts arguments from a constructor. It implements equal, not equal, get hash code, the deconstructors, which got introduced recently, and also with, which is pretty new. So to make this easier to work with, well, let's say here that we introduce now a new point, a 3D point that takes x, y, and z. I don't want to have to re-implement all this, so I want to use the points that I have from x and kind of polyfill. So in the constructor, I can substitute the z value here, and then I can do a this operator for self things. So, and then we get to the this. There you go. This really wasn't, this is not exactly the slide I thought was coming up. So this is basically showing you if you want to extend the point or create a new point that has additional values, you can encapsulate them and build off them together. You don't have to do point 1, point 2. There's ways of planned ways to work with that. But what's really exciting, I'm just going to go through that really quick, is with expressions. So with your class, let's say you have var point p equals new point, and this can't change. This point will always be 4 and 8. That's it. That's what immutability is. So if you want another point, you'd have to new it up, maybe pass in point.x, point.y, or you can use the with function, which is being added. And there you can do with y. You can specify any of the arguments you want, x or y, pass in the new value, and it builds you a whole new point with that substitution. And to make it a little bit nicer to look at, this will become a keyword in C#, so the syntax flow is a little bit nicer. So that's pretty cool. So those are all the major features on the horizon for C# 8.0. And we got 5 minutes left, so I want to see if there's anything you wanted me to explain a little bit more. There are a ton more features. I have like the next 4 slides that just pop these things off of all these things that we're considering. I can go through them real quick if you want. The slides will be posted online if you want to take your time later. If you want to go online to the Roslyn site's GitHub repository directly, take a look at these features in more depth. So any other things I can answer for you this morning, or attempt to answer? All right, so let's go through these really, real quick. I'm going to talk fast just to give you an idea, to get your excitement up for things that could be coming if one of these, is interesting to you. So if you had an unconstrained generic, you couldn't use the is null pattern. There's a feature coming up to allow you to do that. This is the allowed default I was kind of talking about before, where you can just use default as an expression. It'll automatically fill in both the types. Useful for tuples. Slicing, pretty cool. So if you want to get a view of an array or get a subarray from a large array, you can use, there's span that was introduced as a new type in the framework. And there's now C# support for slicing here. It's still under construction. It might be ... It might be colon. They're still working on that. I think the ... might get more of a push behind it. But the idea is that you can take an array and get a portion of the array. It's not a copy. It's just it's a slice. So it's an actual type that is just constrained to those points that you asked for. Native number support. So like if you use int pointers today of unmanaged memory, they will still be dependent on your operating system size, or your So if you have 32-bit operating system, you get 32-bit pointers. 64-bit operating system, 64-bit pointers. But if you want to deal with these in the language other than int pointers, there's really no support. That's being considered for n-int, n-unit, and n-float. So these things are kind of coming out there. These are just ideas. None of these may actually make it out, but they're all under serious consideration. Fixed size buffers. This will help a lot with low-level programming, interacting with microcontrollers and the like. This one I think personally is a little frivolous. It's the negated if condition. So if you want the opposite of an if condition, they may now allow you to put a not operator outside of the braces to make it, I think the idea is to make it a little more obvious what it's doing. There's already so many ways to do that. I'm not behind this one personally. Yeah, so there is going to be probably a not introduced in C# eventually as part of pattern matching. So that might pop up too. But yeah, there are other languages. I think C++ still has not to. Null coalescing assignments. So there's been a lot of code. So if you would check if x equals null, then set s equal to y, otherwise do nothing. That's a pattern that people have in their code quite often. I have that in my code quite often. So there's the null coalescing operator, which will do that very simply in 3 characters. That's pretty cool. They're also considering and or. I think the null coalescing will have a good chance of getting in there. Null conditional awaits. So basically, when you wait on something, if it's null, it returns immediately. A targeted type new expression. So it's basically just saying implicitly get it from the left-hand side, which is more of a Java-ish thing. So I guess it knows it's doing point P because I declared it to the left side. So I don't have to repeat the name on the right side. This is kind of opposite with how vars work, so I don't know if this is really right for C# necessarily, but it's under consideration. It is kind of the way more so that Java generics seem to work. Yeah. It's all coalescing. Well, I think that some of the language designers overlap. Seriously, I think it's the same people working on some of the same language features across both C# and Java and some other languages as well. So a lot of the similarities do come up. Mixing fresh and existing variables. So if you want to do a deconstruction, they either all have to be existing or all have to be declared new. Now they're working on some syntax. It's not really clear what this is doing, so the syntax is still a little wishy-washy, but ways to mix them together if you want to both declare one and use an existing one. Otherwise, you have to get a little more creative in your naming, like resort to A, B, or 1, 2, and that's just no. Ternary, now this is pretty cool, implicit conversions. So if you are running like int or a double, the compiler could convert from an int to a double, but it's not going to do an automatic conversion with ternaries. So they're looking to add that support. I don't know how this is going to get implemented because there's a lot of knowledge you need in order to make that kind of assumption. So I don't know in what capacity that'll make it in, but it's still pretty exciting. What I think has a pretty good chance of making it in is something I've wanted for a while, is some implicit kind of understanding for nullable ints or nullable reference types. So if one of them is a reference type, the other one is null, it can return to you a nullable reference type automatically. Today, you actually have to cast that null specifically to an int question mark in order for it to pull the correct value. Because it will do int and int question mark, but it won't do int and null. So we're going to add that feature, and that's one that I wished existed for a while, just a small little annoyance. Declaration expressions. So within a, kind of like out bars, but within a declaration of an if statement or some expression, to be able to declare a variable. Something they're looking into. Dictionary literals, just to make it a little bit easier to work with, that might make it in there. That's a pretty good shot. UTF-8 string literals, pretty much what that is. I can't explain that any better. And then to allow no art constructors and field initializers in struct declarations. So if you're dealing with struct, you get a few more options for how you can initialize them. So I know I went through those really, really quick. Just want to give you an idea for what's out there. Please look more into this if you want. I'll be around, not right after this, but later today after lunch to chat if you want. And thanks for coming. That's our time, and that's everything with C# needs. So C#'s future. Thank you.